In this video, we will be talking about the best way to solve a linear system. So we're going to identify whether to solve the system by graphing, elimination, or substitution, and then being able to solve a system with any of these three methods. First of all, for our methods of solving, is the equation in the form of y equals mx plus b? If both equations are in the form of y equals mx plus b, we may want to solve the system by graphing. The other thing to take a look for is we want to make sure that we have smaller numbers because we don't want the graph to be too big. Is there one equation that has a variable by itself? And if there is only one equation that has a variable by itself, then we might want to consider doing substitution. That's where we would substitute into the second equation and solve. The third example, do the variables line up? If they do, and they're vertically stacked, we might want to use that to solve the equations by using elimination. Let's take a look at our first example and see if we can make a decision of how we want to solve. We have y equals x plus 5 and x plus y equals 1. Notice that I have one equation that is solved for one variable. So we might want to use substitution to solve this equation. Remember, I have the y by itself, and y is equal to this expression x plus 5. So I'm going to substitute that expression into the second equation. I'm going to rewrite the equation x plus, substituting in my expression x plus 5 equals 1. That eliminates the y variable and allows me to have an equation in one variable to solve. So I'm going to combine like terms. 2x plus 5 equals 1. I'm going to subtract 5 from both sides, and I have 2x equals negative 4. Finish solving by dividing by 2. So I have x equals negative 2. That is the first part of my ordered pair for my solution to my system. Then I can take the negative 2 and plug it back in to either equation. The top one might be quicker. I'm going to take out the x and substitute in the negative 2 plus 5 and then simply do the math. Negative 2 plus 5 is 3. That is the second part of my ordered pair, which is the solution to my system. And if I had graphed this, at this point is where the two lines would intersect. Let's plug that into the second equation just to be sure it works. Negative 2 plus 3 equals 1. That is the solution to the system. Here's our next example. Select the best method and then solve the system. Notice that my variables are lined up vertically. I would say elimination might be the best method for this particular system of equations. With elimination, we want one of the variables to be the exact opposite. So I could find the least common multiple for 5 and 3, which would be 15, and we would want one of these to be positive 15 and one to be negative 15. I could also have the y's be opposite, 2, and I could make this y be a negative 2. That's what I'm going to choose. So I'm going to multiply the entire equation by negative 2. Negative 2 times negative 3 gives me 6x. Negative 2 times y is negative 2y. And negative 2 times negative 2 is positive 4. I'm going to rewrite the top equation right on top of this one. And then I'm going to add the two equations together. Negative 5x plus 6x is 1x. 2y and negative 2y is 0. 14 plus 4 is 18. That's the first part of my ordered pair, which is the solution to my system. Now I'm going to substitute the 18 into one of the equations, doesn't matter which one. So I'm going to take negative 5 times 18 plus 2y is equal to 14. So negative 90 plus 2y equals 14. I'm going to add 90 to both sides. 2y is equal to 104. And when I divide both sides by 2, I get y is equal to 52. My solution would be the point 18, 52. And if we were to take the 18 and multiply it by negative 3, I would get negative 54. Then if I add 52, my answer would be negative 2. So that is correct. It is the solution to the system, which is the point of intersection if we were to graph. This is a really good example of one that we maybe wouldn't want to graph to solve because the numbers are so large. Let's take a look at our next example. We have y equals negative 2x plus 7, and we have y equals 4x minus 5. This might be an example of one that we might want to solve by graphing because these are both in the form of y equals mx plus b. So let's take a look. In our first equation, we have y equals negative 2x plus 7. My y-intercept is at 0, 7, and my slope is at negative 2, which is negative 2 over 1. So I'm going to put my y-intercept to the point at 0, 7, and then I'm going to use my slope to find my other points. Down 2 over 1, down 2, and over 1. Then I'm going to graph that line. Be sure to label that line with our equation, which is y equals negative 2x plus 7. Then we're going to graph the other line, y equals 4x minus 5. So my y-intercept is at 0, negative 5, and my slope is at positive 4. So I'm going to graph the point 0, negative 5, and my slope will be then up 4 and over 1, up 4 and over 1. Then I'll graph my line, being sure to label as y equals 4x minus 5. And I look for the point of intersection, which is right here, and it is the point positive 2, positive 3. The solution to my system is the point at which they cross, 2, 3. Could have also solved this one by substitution, where we could have taken the negative 2x plus 7 and substituted that into the y and solved from there. Or we could have also solved it by elimination, by multiplying the top or the bottom by negative 1 for the y's to be opposite, or the top equation by 2 for the x to be opposite. So in review, if you are graphing, it's easiest if your equations are in slope-intercept form. If you are using the method substitution, you want to be sure that one of the equations has a variable that's by itself. And if you're doing elimination, make sure your equations are lined up, that the variables are up top of one another, and you have one of the variables being opposite. Please continue by doing the reflection.